Example D wants us to solve the equation sine of 2x is equal to cosine of x. And the hint here is to use trigonometric identities. So we know that there is a double angle identity we could use for sine of 2x. So we have sine of 2x is equal to cosine of x, and this we can replace with the double angle identity, which is 2 times sine of x times cosine of x is equal to cosine of x. And that becomes really helpful because now we can divide both sides of the equation by cosine of x, and we will get rid of the cosine of x on the right-hand side of the equation. And now from here, I can divide both sides by 2. And so we get sine of x is equal to 1/2. And if we apply the inverse function, we get x is equal to sine inverse of 1/2. And if we draw this on our unit circle, sine is going to equal 1/2 in quadrant 1 and in quadrant 2. So our goal is to figure out these two angles. So that happens here at pi over 6, and then happens again here at 5 pi over 6. So our solutions are going to be pi over 6 plus 2 pi k, where k is an integer, and also 5 pi over 6 plus 2 pi k, where k is an integer. Example E says 4 times sine of theta times cosine of theta plus 2 sine of theta minus 2 cosine of theta minus 1 is equal to 0. Now I'm going to break these up into two separate parts. Okay, so in the first set of parentheses, I'm going to factor out the greatest common factor, and that is going to be 2 sine of theta. And left over, we will have, 2 cosine of theta plus 1. And I'm going to factor out a minus 1 out of the second set of parentheses. And so we're basically factoring by grouping here. And what's nice is that whatever's left over inside of the parentheses match with each other. And so we can now factor that out. And we'll be left with 2 times sine of theta minus 1 equals 0. And now we have these two equations or factors that we can set equal to 0 using the zero product principle. And if we solve this first equation, we end up getting cosine of theta is equal to negative 1/2. And this second equation, if you solve that, you get sine of theta is equal to 1/2. Okay, so let's draw a unit circle for the first equation. So we have cosine of theta is equal to negative 1/2. That happens in quadrant 2 and quadrant 3. So we're trying to locate the angle where the x-coordinate of the terminal point is negative 1/2. And that happens when our angle is 2 pi over 3 as well as 4 pi over 3. So for this equation, we get solutions where theta is equal to 2 pi over 3 and all of its coterminal angles, and 4 pi over 3 and all of its coterminal angles. And then we still have to find the solutions for this equation, but luckily we just solved that equation in the previous example. And if you don't believe me, I'm going to scroll up in just a moment. So we solved sine of x is equal to 1/2, and we ended up getting these things as our solutions. So I'm not about doing extra work or more work than I need to, so I'm just going to copy the answers that we got from up above, which was theta equals pi over 6 plus all of its coterminal angles, and the other one was 5 pi over 6 and all of its coterminal angles. So yay for not having to do extra work. Okay, that concludes example E.